Well, hello and welcome back to Swamp Notes. This week we're going to be talking about how to use the soil textures to determine what category of hydric soil we might have. And the Corps of Engineers has basically broken up all the soils in terms of indicators into three broad categories. We have A, S, and F. And the A, S, and F have to start off with texture class. So when we're looking for a hydric soil, the first thing we ask is, what's the texture? Well, now we know what the textures are, determining based on the rub test, or whether you use the chemical tests, or wouldn't recommend the cheap gum thing, but some sort of test. And the idea basically is we're going to go from A, S, or F. Now, the way they break it down is A is actually kind of the funny one because it actually is regardless of texture, and that's what the A class means. So essentially with the A's, texture is not a consideration. Now, that does have a texture in some cases, but these indicators are not texture dependent. So for example, I'll give you one that's we often run into. It smells like rotten eggs. Okay, it's a hydrogen sulfide smell. That's actually a hydric soil indicator, and that would be an A indicator as a result of that because it stinks. It smells like rotten eggs. That's it. Actually, we get a kind of a 2-for-1 deal because it's also technically a hydrology indicator for soils as well, for wetlands as well. But in the soil science world, it is strictly a soil indicator. So we basically have but that has nothing to do with texture, and that's the point of it. Is A's, like, it's smelling isn't a function of texture. That's just simply it smells. Okay, so that no matter what texture it is, it would still smell. So those are the A's. Now we have some ground rules with these. We're going to go through these, and I'll kind of jump into that in a second. But let me go through the other two. The S's, as you might suspect, is S as in sand. Okay, so we're talking about sand. So A is all soils, S is sand, and sand is sand. Now sands have specific size classes, as we talked about before, to make it a sand. So we're talking about it should end with sand, silty sand, or sandy loam, or maybe, well, sandy loam might still be a little bit too minerally, or too less sand, but a loamy sand or something like that. Where basically the idea is the preponderance of the texture is sand. We're talking about basically beach sand. And as you might suspect, having a hydric soil associated with sand could be a challenge because sand drains well. So if we have something that drains well, it's not likely to hold water. So those are the S's, and there's a lot of variations on what is considered a hydric soil in the S category. And then finally, the F's. Now the F's are the most common kind of inland soil type that we run into that's associated with wetlands, and F is basically fine sand and finer. The F stands for fine sand, so it's still related to that texture class. We often thought it was like ferric or something like that. It was never explained what F meant, but that's what it means, fine sand or finer. You can use your imagination. If you're a developer and you have this type of soil on your property, you may have another interpretation of that. But the upshot of this basically is that we have a very, very fine texture, meaning mainly the silts and the clays. And the silts and the clays are going to hold those waters tighter, so we're going to be looking for evidence for water to basically being stuck in the soil. And that's essentially where the F's come in. So what I want to do now is jump over back to our bigger slides to show you how we delineate the differences. And now we've got some ground rules for these different types of indicators.
Okay, just a quick little view, a little bit closer, easier to read slide. The indicators, now AS or F, this is some ground rules that apply to all. Now, it does preface that there are other indications where some of these may be exceptions to the rules, but these are the general ground rules for any of the hydric soil indicators. First and foremost, the dominant chroma must be 2 or less. Now, when we get into chroma, we get into soil color, but basically the chroma should be a grayish color. It's going to be in the lower chroma numbers, which is a soil color. Then layers with a dominant chroma which is greater than 2 or more than 2 must be less than 6 inches thick to meet any hydric soil indicator. And this is kind of it's new with the regional supplements, but the idea is that there's a thickness requirement, and that if you have a chroma within your upper part that's greater than 2, the color is brighter essentially, then that thickness must be less than 6 inches of that bright color, otherwise it kind of kills it as a hydric soil. And then finally, nodules and concretions are not to be considered redox concentrations unless otherwise noted. And nodules and concretions are indicative of some sort of redox feature, but they're not necessarily local to the place that you're taking a look at it. So that's just a quick overview of what the indicators must have.
Okay, I hope that was helpful. Now, to determine whether we have a hydric soil, there's a couple basic premise behind this. One is chroma is less than or equal to 2. You'll notice there was a trend there as we went through the sequence. Chroma is less than or equal to 2 is a starting point. If we have chroma is greater than a 2, especially in the F categories, there are exceptions to that rule. We deal with red parent material, with dark parent material, depending on where you are in the country. There's some exceptions to that rule where we may have some strangeness to the indicators. Also, landform factors in. Vernal pools, things like that will factor into it. So those are exceptions to the rule. Floodplains, things like that. There's lots of exceptions to less than or equal to 2. But generally speaking, less than or equal to 2 is a hydric soil. At least we think it might be a hydric soil. If we have it greater than 2, not likely to be a hydric soil unless we have a special circumstance. Second thing is that we're looking at these redox features being required in many of these indicators, but we have this thing called redox concentrations occurring basically as soft masses and redox concretions. We're basically looking at the concretions as a problem. Soft masses are good, concretions are bad, largely because the concretions tend to migrate through the watershed and they stay stuck in their color, so it doesn't necessarily mean you have a hydric soil or basically a true redox feature. It may be a remnant from someplace else, so that's why we don't automatically count those. Good news is that there are indicators just for those circumstances, so we have that. And then the other issue that was kind of a new thing that, I mean, the USDA developed this, but the Corps of Engineers never really dealt with this, which was thickness of feature. And remember that if we have in our upper part, which is usually our upper 12 inches, if we have a color that's brighter than a chroma of 2, then that thickness of that layer has to be less than 6 inches. Otherwise, it's basically a hydric soil killer if we have too much. So if we just have this little band of gray stuff and then we get this, brown stuff, chromas of 4 or 5s or something like that, it's not going to be a hydric soil, even though you got this little brown. You might be looking at an E horizon, which might be one of the issues, which is what this kind of encountered. So anyway, lots more to talk about. Obviously, we can't cover all the short little note, but just giving you a heads up on this. So if you have any questions, drop us a line. We got some great soil classes. If you want to dive into this some more, we'd love to have you in our class. We're just kind of giving you some teasers here. But at any rate, let us know what you think. Drop us a line. And again, we'd love to see you in the swamp. Take care.